Okay, so let's get down to it. Last class, yesterday, I don't know why I'm thinking a week. Last class, we looked at oxygen. Now we're going to do a quick review. I have some images and I'll call on the first person that I see type the correct answer in my chat. So first question, what is the chemical symbol for oxygen? First answer, O2. Excellent, thank you, Andres. O. So remember, Marion, it's not CO. CO is carbon dioxide. It will just be O for oxygen. Excellent. Next one. When oxygen combines with a substance, a reaction takes place. What is this reaction known as? A reaction that begins with O. What is this reaction known as? Very, very close, Andres. I know what you're trying to say. You're not spelling it correctly, but I can see what you're trying to say. So I'm going to give it to you. It is oxidation. So remember yesterday we talked about oxidation, and when oxygen is exposed to certain chemicals, a reaction takes place. And we talked about when we look at our apple, if you were to cut that in half and leave that on your counter for a few hours, you would notice it starts to turn brown where the oxygen comes into contact. So very good, Andres. Next one. When we look at oxidation, there are two types. One of these types would take a longer time for a change to take place. And this is an example of that type. Who can remember the name of that type of oxidation? So I'm waiting on my answer. Metal oxidation. What is the name for it? Make sure this is, see if people are really taking notes. So there are two types of oxidation. One is works quicker, one takes a longer time to work. Which one would this be? Good, thank you, Cindy. It would be slow oxidation. Remember we said with rapid oxidation, this is like a fire. The minute you expose oxygen on it, the fire increases. With slow oxidation, it's like metal, or we said it's like our fences in our yard. It takes a longer period of time, but over time it starts to rust and corrode from being exposed to oxygen. So very good, Cindy. Next one. If we do not have enough oxygen to make up this layer of the atmosphere, we are at risk of getting cancer, eye disorders, and killing organisms. What layer of the atmosphere does oxygen contribute to? Good job. So, Omarion told me, Cindy, and come on up. So Marion and Cindy told me ozone layer. Excellent, very good. Oh, I short, but that's fine. This next one, this describes how we can test for oxygen if it's present. What is that little green thing that is being used called? What is the name of that green thing? A splint. Excellent, Ricardo. So remember we said if we wanted to test for oxygen, we could light a splint, which is just a little thin piece of wood, and blow it out. If we put it by a test tube mouth and it relights, oxygen is present. So excellent, Ricardo. Last one. This common household item can be prepared in the lab to obtain oxygen. So what do we have in our homes right now that we can take into the lab and get oxygen from? Good, excellent, Omarion. And Cindy, hydrogen peroxide, great. So now we're gonna move on to carbon dioxide. But first I want us to quickly go over this. Everyone should have gotten this yesterday. So I'll look forward to seeing some more of these in my inbox before I begin with the answers for this, okay? Now for those who supposed to breathe with no air and password for the video, I'm going to post it up in the chat now with you all. So if you were not here and you missed the lesson, you can click on that link and you can put in that password and you'll be able to see what we did yesterday, okay? So now we're gonna move on to carbon dioxide. Let's make sure that we have our books out, our pens ready, and we're ready to write. by the responses, the slow responses that I was getting from the answers that I just gave, I want us to make sure that we are getting our notes and we're reviewing. So carbon dioxide, we learned about oxygen, now we're going to learn about carbon dioxide. It is a chemical compound composed of one carbon and two oxygen atoms. The chemical formula is CO2. So oxygen was just a large O with a small 2. The carbon dioxide is CO with a small 2. Carbon dioxide makes up 0.03% of air. So although it is needed for plants, it still makes up a very small portion of the air. Yes, write this please. It is colorless, tasteless, and odorless. The only time that any of these properties would change is if it's dissolved in water. So write this for me, please, and let me know when you're ready. Now, Marion using his screenshots. Pretty sure I have some others who are snapping photos, but for my good old-fashioned people like myself who like to write, I'll give you a minute. So I need a few more persons to tell me when they're ready. Okay, so in regard to your question, Andres, about it changing color, carbon dioxide is colorless. Only when it's exposed to certain chemicals will it change color. And we're going to look into that when we look at testing for carbon dioxide. So that's a very good question. Okay, so we can move on. Other properties of carbon dioxide. It is more dense, and dense is just the scientific word for heavy. It's more dense than air. It is soluble in water. And remember we said soluble means that it breaks down in water. Now, when we expose carbon dioxide to water, it forms a weak acid known as carbonic acid. And can someone tell me where we can find carbonic acid? Let me see if anyone knows this. I'll wait for my answer as I go on. It is also present in drinking water because of its high solubility. Now, yesterday we learned about litmus papers. What happens with carbon dioxide? Because it is a weak acid, it turns a blue litmus paper pink, which shows that there are some acidic conditions present. That is the password for yesterday's recording. I'm not sure if it's going to be the same for all. Okay, Omarion. So remember yesterday we learned about the litmus paper. We said blue litmus paper turns pink or red when it's acidic conditions, and red litmus paper turns blue when it's alkaline or basic conditions. If you test something to figure out if carbon dioxide is in it, it would turn blue litmus paper pink. The reason is because carbon dioxide produces a weak acid, and blue litmus paper tests for acidic conditions. For example, if you had blue litmus paper home and you were to open a few bottles of different beverages in your home, you would notice that a certain beverage would change color because it has carbonic acid in it. And we're going to look at that in the next slide. So let me know when we're ready. Okay, I'll give you 1 more minute. Yes, Sinead, very good. It is a carbonated drink, so it would be slightly acidic. Sinead mentioned about Vitamalt, which is good. Vitamalt is a lightly carbonated drink. Okay, so let's look at our next slide. Sodas, something that a lot of us love to drink that is not good for us at all, is a carbonated beverage. So sodas have carbonic acid in it, and it produces a fizz and water. So a lot of times if we were to shake up a can of soda, we would end up seeing that it would spout all over the place. The reason why that occurs is because as you shake it up, you're forming tiny bubbles of carbon dioxide. And these bubbles stick to the side of the bottle. Now, when you open that, these bubbles can expand a lot and they end up pushing straight out of the soda, and that's what causes that explosion. So sodas aren't good for us. Too much acid in general isn't good for us. So if you are a person who loves to drink a lot of sodas every single day, you want to cut back on all that carbonic acid that you're taking in. The most dangerous soda right in the front, Coca-Cola. Yes, interesting, Andres. Looks like you are a great scientist. You love to experiment. She is too young for sodas. So we want to cut out sodas, replace it with water. That's why when we first take that drink of soda and you could feel that slight burn when you rush and drink a soda, that's actually that carbonic acid that you're feeling. If you have any questions, feel free to type it in the chat. I'll answer it as I go through. Go ahead, Sunay. Sodas can be found to increase acne production. You can research it. When it comes to sodas with the amount of sugar and acid, they've found that it can increase or block some of our pores. So it is good. If you drink a soda, I always say that if you drink a soda, it's good to double it by drinking about 2 to 3 times that in water to help flush that out of your system. Nothing would really happen, Renan, if you mix all of the sodas together. Some persons like to mix the different sodas. All of them have the same carbonic acid in it, so it's not going to cause a reaction. I don't know how it'll taste, but that's a whole other discussion. So can we move on? Okay, so let's move. Next one, carbon dioxide can also be used to produce dry ice. So dry ice is just a solid form of carbon dioxide. Unlike water ice, when dry ice warms up, it sublimes, changing from a solid directly to a gas. So all this means is dry ice is a solid form of carbon dioxide. If you were to heat it, it wouldn't change from solid to liquid to gas. It would go straight from solid to gas. And they love to use dry ice when it comes to keeping things, preserving food. So you would normally find dry ice in refrigeration. It's used to package items that must remain cold or frozen. So a lot of times when we have ice cream and even biological samples, if we were to go in a lab, they use dry ice for that. Yes, good, Renan. They use it in movies when you see all those smoke effects and different things happening. That is dry ice they're using. I have Sinai. I tried the dragon breath thing. I know they use that for dry ice. It was so weird, but it was a really cool effect. Yes, it is cool. So, like Sinai said, if you go to the United States, they have these little balls that they actually keep drenched in the dry ice. And as you chew them, you could see the dry ice coming out of your mouth as you're chewing. So it's a cool effect. I think I actually even recorded myself doing it before. If we were in a classroom, I would have showed you the video. Because, good question, Ricardo. Dry ice is heavier than air because carbon dioxide, remember we said it's denser than air. So because carbon dioxide is heavier than air, as you see in this photos, it goes downward before it comes upward. Okay, great questions. Let me know when you're ready to move. So I encourage you all, if you're ever in the United States and at a mall and you see those little dragon breath stalls, I trust me, you won't miss it. You know it. You can try it out for yourself. So 2 persons that said are done. I need 2 more so I can know we can move. Okay, I'll give you a minute, Cindy. Okay, good. Next one. Another use of carbon dioxide is for photosynthesis. All of us love plants, all of us need them. I'm sure all of us go outside and water the plants that are around us because we need them for oxygen. So they need us in return to help to keep them safe. But they need carbon dioxide for photosynthesis because green plants use carbon dioxide to make their own food. So it's important that they have carbon dioxide. As we can see, there is a large percentage of oxygen in the air. We remember from yesterday that we said there's 21% of oxygen. And the reason why that percentage is so high is because plants give off oxygen when they're finished their process of photosynthesis. So by doing that, we're able to take in oxygen. But in order for that to happen, they also need to get carbon dioxide. And we have a very good relationship with plants because as we breathe out from our process of respiration, we're breathing out carbon dioxide and we're taking in the oxygen that they're letting out. So that's extremely important for us. Another reason why we need carbon dioxide is because of fire extinguishers. Remember we said oxygen fuels fire. The more oxygen you put on something, the higher the fire will be. However, when it comes to carbon dioxide does not help things to burn. So if you want to put a fire out, you use carbon dioxide. So all a fire extinguisher is carbon dioxide trapped in that bottle. And what happens is, as it is trapped, the carbon dioxide is very cold inside of there. So by the time as we let it out, it actually cools the fire down and helps to put it out. Yes, good, Jasmine. So we have a symbiotic relationship with plants. We give them carbon dioxide, they give us oxygen. We let out carbon dioxide as a waste product, they let out oxygen as a waste product. So it's a continuing relationship where we work together. That's why it's always important that they tell you surround your home with plants. The more plants you have, the more oxygen is being produced, the better you'll be able to breathe. Animals also need oxygen. So they would not take in oxygen we give out. We give out a lower percentage of oxygen than we take in. We take in about 21% and we give out about 16%. So we use up some of that oxygen and we actually produce more carbon dioxide when we breathe out. So remember, oxygen fuels the fire, carbon dioxide puts it up. That's why if you have a fire, they tell you to suffocate it. And when you're suffocating it, you're cutting it off from oxygen and you're increasing the carbon dioxide. And that's what helps to put a fire out. So let me know when we're good to go. Okay, 3, 4, good. Yes, Renee. So there is what we call a balance between carbon dioxide and oxygen. Remember, oxygen is about 21% in our atmosphere. Carbon dioxide is about 0.03. That is the balance that it needs because the more carbon we have in our atmosphere, the hotter it would be. And we're going to look at the carbon cycle and how global warming happens in our lessons in the future. But that balance right now that it is the perfect balance. We don't want the amount of carbon dioxide to increase in the environment because it would be worse for us. No, fire extinguishers aren't completely dry ice. It's, well, you would say it's smokier, but it's just cool carbon dioxide. It isn't completely dry ice, although it's still a little similar. Okay, so let's move on. Our next use of carbon dioxide, which all of us would love, is freshly baked bread. We use carbon dioxide when it comes to baking, whether you're baking rolls, bread, cinnamon rolls, anything like that, you need carbon dioxide because carbon dioxide is what helps our bread to rise. So normally if you are a baker, you know that you would add yeast to a mixture. And have you ever wondered why they tell you to add yeast and let it sit for an hour or 30 minutes? The reason why is because when yeast is exposed, it produces carbon dioxide. And carbon dioxide produces those bubbles. And as it produces bubbles, it causes that bread or that dough to rise. So in my picture to my right, you can actually see the process of how that bread rises as it is exposed to carbon dioxide. And that's another reason why with bakers, they would tell you to cover your dough and let it rest for 30 minutes. By doing that, you're cutting off the oxygen that is exposing itself to the dough and you're allowing that carbon dioxide to work. Yes, Andreas, because all a fire extinguisher is trapped cool carbon dioxide. So once you expose that, it's going to come flying out. So if anyone ever used a fire extinguisher, you would notice that the air coming out of it is cool. And that's what helps to put our flames out. So let me know when we're good to go. And we all know why. So the next time you see your aunt, your mom, your cousin, anyone in the kitchen baking, you can explain to them why they need to put yeast in it. And they'll say, oh, wow, you're really smart. I didn't even know that. So share the knowledge to them. I have 2 persons done. Give me a few more. Remember, carbon dioxide, Diarrhenic, is colorless, odorless, and tasteless. It is safe for us to eat because we're breathing it in anyway and we're also producing it. So it's not dangerous for us to do that. Someone said their mom is baking bread now. That means after class you need to go ask her, Mom, did you put in the yeast? Because we need the yeast in order for the bread to rise because the carbon dioxide is being produced. I bet you she look at you in amazement. So let's move on. We're going to see now how we test for carbon dioxide. And testing for carbon dioxide is one of my favorite experiments because it's very simple. We can do it very easily in class. So let's watch this video and then we'll discuss it.
So you need to know how to test for a number of different gases in your GCSE. This comes up all over the place in the GCSE, and this is the test for carbon dioxide. You need some lime water in a test tube, and the source of carbon dioxide that I'm going to use today is me. So I have a straw, and I'm just going to blow into this straw. And hopefully you can see that the lime water is starting to go cloudy. This is because the lime water is calcium hydroxide. As we add the carbon dioxide into it, it turns into calcium carbonate, which is the cloudy precipitate that you can see.
Okay, good. So this video just showed how we can test for carbon dioxide. All we need, well, one of the ways that's very easy to test for carbon dioxide is to obtain lime water. Now, when we first look at lime water, it is clear like regular water, but as it is exposed to carbon dioxide, it turns into a milky color. And that's how we know carbon dioxide is present. If we were in class, your teacher would have probably gotten a test tube, put some lime water in it, put a straw in it, and then let you blow in it to bubble it. The more that, remember as we breathe that we're producing carbon dioxide and we're letting it out. So as you blow into the straw, you're actually blowing that carbon dioxide that's coming out of your body into the lime water. And that's going to change the color of lime water. So that's the easiest way to test for carbon dioxide. Another way is similar how we test for oxygen. We remember that we said that when we test for oxygen, it relights a glowing splint. However, if carbon dioxide is present, it would actually put out that splint. So that's an easy way for us to remember the difference. If it relights, oxygen is present. If it doesn't, then carbon dioxide is present. So let me see my question. No, who's that? That is Omarian, no. So it's not made of water and lime. It's actually made of calcium hydroxide. So that is a solution with calcium hydroxide is mixed together. That's what makes lime water. And yes, Kezia. So we use carbon dioxide for so many things. We even produce carbon dioxide. But if we expose ourselves to too much carbon dioxide, it can be detrimental for us. So it shows where everything in life is balanced. You need everything, but you need it in the right amount. No problem, Liana. We're glad to have you. Let me know, everyone, when we're ready to move. Yes, very good, Renan. We're going to actually look at that in our next slide, how we can test it. So you're ahead of us, way to go. When you're ready, let me know. I think 2 persons said they're ready. Give me about 2 more and then we can go. Good. So next one, we're going to look at what Renan started to tell me in more depth. So remember when we did oxygen, we looked at how to test for it and also how to prepare it in a lab. So we need to know how we can prepare carbon dioxide in a lab, just in case we ever need more. So we're going to watch this video first and then we're going to do our explanation.
To prepare carbon dioxide in the laboratory, let us learn How to prepare carbon dioxide in the laboratory. Put some marble chips, like calcium carbonate, in a round bottle flask, fitted with a thistle funnel and a delivery tube. Place a collecting jar at the other end of the delivery tube. Pour dilute hydrochloric acid in the bottle through the thistle funnel so that the marble chips are covered with the acid. Effervescence takes place in the bottle flask, and the gas is collected by upward displacement of air at the other end of the collecting jar. Observe and test the properties of the gas formed. It is colorless. It has a faint odor. It is heavier than air. Put a lighted splinter in a jar containing carbon dioxide gas. It extinguishes. The gas does not support combustion. Hence, we conclude that the gas given off is carbon dioxide. The equation for the laboratory preparation of carbon dioxide is CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2.
Okay, so for those of you who want to go into chemistry, you would notice that it gave a chemical equation at the end. So that's how chemists always know the balance of how they can expose certain chemicals and substances in order to not create a detrimental reaction. But when we look at it for general science, the main thing we need to know is the process of how we can get carbon dioxide in a lab. So how we do that firstly is carbon dioxide is prepared in the lab by adding dilute hydrochloric acid. It has to be diluted to marble chips. All marble chips are pure forms of calcium carbonate. Now, carbon dioxide gas is made by adding hydrochloric acid drop by drop over the marble chips. This gas is then collected in by the downward displacement of water. So the whole process of it can be seen to the right. This is how you would set it up. At the bottom where we have our marble chips is where it would be lit so that the flame can help to release that carbon dioxide, and then it would travel through our delivery tube into our figure to the right, and that would be where they would get the carbon dioxide air. So these things are needed. We need to know these things because if we're ever in a scenario where we need more of a certain gas, then we need to know how we can get it. If we need to increase carbon dioxide in certain cases, we need to know if it's not readily available in our atmosphere, what can we use around us to help to produce this? Even with oxygen, what can we use around us to help to give us more of it? So that's why chemistry is so important. So I have one person who's finished. Good morning, Daniel. Is everyone else finished or do you need another minute? Okay, I'll give you another minute, no problem. 3 persons, 4 persons. I see those persons raising their hands. For the moment, I want you to type it in the chat, but as soon as we're finished content, I'm gonna do the same thing that we did yesterday, and I'll allow you all to raise your hand if you have a question about the lesson so you can speak. Okay, everyone's done. 1 more minute, no problem, Cindy. So let me know when you're done, Cindy, so I can go. Okay, so let's look at our last slide. And this is a very fun and interesting experiment that you can actually carry out at home because you probably have all of these things right at home. But of course, I want you to get permission from your parents first before you do it. But let's watch the video and then I'm gonna explain why it's happening. So what is happening here in this video? They combine baking soda and vinegar. Now, vinegar is also an acid and baking soda is a base. It's alkaline. So when they combine together, it creates this acid-base reaction. And this now produces carbon dioxide bubbles. So that carbon dioxide that's building up and those bubbles that are releasing is what causes that balloon to start to inflate because the gas is being expanded. So this is a cool experiment that we can even do right at home. All you need is a balloon, a little baking soda and vinegar, and you can blow them up. For persons who are probably similar to myself, for the life of me, I cannot blow up balloons on my own. So I would probably like to use this when it comes to blowing up balloons. It's like a simple and easy way to do it without having to put in all that effort. So now we're going to end the lesson today with a worksheet on carbon dioxide. So again, I want you all to make note of this. At the beginning of the next class, we're going to go over both the oxygen and carbon dioxide worksheet. So I need you all to have both of these done by Monday for review. So for now, I need you to write down the questions, take a screenshot, what else do I do? Photo, whatever. Make sure that you have it. And while persons are writing this, I'll now open the floor for questions. So if you have any questions, you can raise your hand and you can let me know. So I'm going to start with Sanai. Remember to keep the questions relevant to our topic. If it's not, do not lose your privilege. I will also, yes, so Shanique, I can put it in the course library. I will also upload it to our page so that you can have access to it. Yes. Sanai, I gave you the right to speak so you can talk. And I am also going to give it to Sasha. But once you have this worksheet written down, then you are free to go. It was great seeing you all. I hope you all learned something, and I'm going to test your knowledge next class. So who's speaking now? Go ahead, Sasha.
So how do we turn in the work?
I'm going to give my email in the chat again, but by next week, hopefully you'll be able to upload your work straight to the page where you get to access the class. So we're working on that development now where you'll have everything in one place. So now you had a question? Okay, anyone else with any other questions that they need to ask before we go? Okay, great. So, oh, hold on, I think I saw someone. Go ahead, Angel. Yeah, no problem, Trey. You can write it down. I'm not moving it. As soon as you tell me you're ready, then I'll move it. Hi, Charlene and Cindy. Okay, Brittany, I'll allow you to speak.
Hello?
Hi, Brittany.
Good morning. So you're saying you send the email for us, so when we finish to the paper, we have to send it to email it to you.
Yes,
And
so when you're finished, you can email me the answers that you did.
okay, thank you.
No problem. Yes, good job. Someone who's anonymous, they said they use vinegar and baking soda for volcano projects. This is an easy experiment that we normally like to carry out to show acid and base reactions. So very good. That's also something you can do right at home. So if everyone has it, you can let me know. Oh, hi, Rudolph. This is good revision for EJC. So all the worksheets that you will be given would be relevant to our national exams and also for what you would need to cover for school. So nothing that we're covering is just something to be covered. All of it has a purpose. So I would encourage you all to take it in, practice it, get it done, so that when school reopens and you do have to do it in class, you already have a sort of background to it. So are we good? Did everyone have it? Does everyone have it? Trey, did you get it? I know you said you were writing it. Okay, Ricardo, I'll wait. Okay, once you have it, you are free to go. Bye, Daronique. Bye, Judah. Yes, Ricardo, either write it down or take a screenshot of it, of a photo of it, so that you can know what you need to complete. Bye, Destiny. Bye, Anike. Bye, V. Bye, Trishana and Angel. Have a great day. Enjoy the rest of your classes. Okay, great. So I think everyone should have it by now. Remember that I gave you all the link and password for the previous session. You can always go back and look at it if you missed it. And I will see you all on Monday, where we will review these worksheets. So make sure to get it done. Have a great day. See you all later.
Hello, sixth graders. Today, our topic is the atmosphere protects us. By the end of the video, you will be able to describe the atmosphere and its function, explain the purpose and importance of the atmosphere, compare the processes by which the atmosphere is polluted. Let's begin with our vocabulary words. Let's say each word together. Atmosphere. Gravity. Pollution. Fossil fuels. Acid rain. Photosynthesis. Yes, sixth graders, those words are familiar to you as you would have already covered them in science. Now, we'll go through the definitions. Atmosphere. The atmosphere is made up of a blanket of gases that surrounds the Earth. Gravity. Gravity is the force that attracts a body towards the center of the Earth or towards any other physical body having mass. Pollution. Pollution is the presence in or introduction into the environment of a substance which has harmful or poisonous effects. Fossil fuels. Fossil fuels are natural resources, for example, coal, oil, and gas that are made from animals and plants that lived long ago. Acid rain. Acid rain is rain that has been polluted by various gases. Photosynthesis. Photosynthesis is the process by which plants make their own food. What is the atmosphere? The Earth is surrounded by several layers which together are called the atmosphere. It surrounds the Earth completely and is about 900 kilometers thick. A blanket of air is held close to the Earth by the force of gravity. Without it, there would be no air for us to breathe, and all living things would die. There would be no wind, and the world would be silent and dead. Therefore, heat and light from the sun are necessary to all forms of life. The atmosphere stores heat, protects us from the bitter cold of the outer space, and shields us from the sun's harmful ultraviolet radiation. Clean air is essential to healthy life. In some places in the world, the air is so polluted that it's not safe to breathe. How does the atmosphere become polluted? When fuel is burnt, it releases harmful waste in the form of gases. These come from factories and also from things made in factories like cars. This polluted air spreads out into the atmosphere and does not disappear. The following video shows some ways in which we as humans contribute to polluting the atmosphere.
Human activities such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change.
The atmosphere over many cities around the world is heavily polluted with various substances. Many of them are harmful. When fossil fuels such as coal, oil, and gas are burnt in factories, power stations, and motor vehicles, they produce sulfur and nitrogen. These gases react with water in the air to make sulfuric and nitric acids. The resulting acid rain may fall far away from the place where the gases were produced. Acid rain is a major pollution problem on the continents of Europe and North America. Let's begin by viewing the map. The key is entitled The Global Problem of Acid Rain. The orange color shows acid rain. The purple shows polluted air emissions leading to acid rain. Now let's look at the continents of North America and Europe, where the peach and purple colors are highlighted on those continents. It's evident that those areas are polluted with acid rain. All rain contains some weak acids because the water reacts with the gases that occur naturally in the air. But in recent years, the rain has become more and more acidic, and it is now damaging buildings, crops, trees, and wildlife. Trees and other plants use sunlight to make food by a process called photosynthesis. They produce oxygen by this process, which is important to animals because they need oxygen to breathe. Acid rain damages the leaves of plants so they can no longer make the food they need or produce oxygen. The following video shows before and after effects of acid rain.
It damages the statues, monuments and tombstone made up of stones and metals. Acid rain decrease the pH level of water. Low pH level kill fishes.
All right, students, let's recap. We can read these together. What is the atmosphere? The atmosphere is made up of a blanket of gases that surrounds the Earth. Remember, the atmosphere is polluted when fuel is burnt, which releases harmful gases. Buildings, crops, trees, and wildlife are being damaged because rain now contains more acid than before. This brings us to the end of our lesson for today. See you next time.